Okay, 12:30 on the dot. We'll start this. Once again, I'd like to thank everyone, I guess, for giving us all a bit of your time today, and joining us once again to one of our community of practices around sustainable concrete. For those who haven't attended any of these sessions, I'd like to welcome you again. I guess the main idea of this community of practice, specifically around concrete, sustainable concrete, is just to provide a platform, an opportunity to bring industry, academics together, experts, researchers, those, I guess, that are understanding and directly involved in what we're currently doing in the industry. So just a bit of a background. So the previous community of practice, we spoke about a loom sludge. We spoke about, I guess, some of the challenges, some of the roadblocks, some of the limitations around that, specifically around the water industry. So that was a really interesting conversation that we had, and that was a couple of months ago. So fortunately, we're here with two great speakers again, and I'll introduce them a little bit later on, but today we'll be talking about the circular economy with a bit of a focus around recyclable materials. We'll be able to understand and gain some knowledge in regards to some of the changes that are occurring, some of these recyclable materials that we're currently looking at, both on an industry scale as well as on an academic scale. Both presenters will definitely touch base on some of the objectives and the main drivers as to why we're even looking at these materials, and I guess some of the design concepts and the changes in design work when it comes to utilizing these recycled materials. So the two speakers today are Professor Rebecca Gravina and Dr. Anumitra Mitri. So just a bit of housekeeping today. Please, if you could put yourselves on mute throughout the entire webinar, that would be much appreciated. So basically, the way in which this will work is both presenters will, I guess, provide their slides and present to us. And then at the end of both presenters have finished, we'll have a bit of conversation and question time. So the way in which this works, you can either at the end of both presentations write your questions in the chat box, or you can raise your hand and just directly ask one of the presenters your question. So one thing I always like to emphasize when it comes to this community of practice is that we want this to be engaging. I guess when it comes to obtaining knowledge, you have to ask questions. You have to actually really engage in conversation. So please don't hesitate at all to jump in to ask any question to either one of the presenters. So without further ado, we will jump straight into it. So I would like to just welcome our first speaker, Professor Rebecca Gravina. She is a professor and Department of Transport and Main Roads Chair of Structural Engineering at the University of Queensland in Brisbane. She also held the position Professor of Civil and Infrastructure Engineering at RMIT University, Melbourne, Australia. Professor Gravina obtained her PhD in structural engineering from the University of Adelaide, and prior to joining academia, she worked as a consulting structural engineer with Arup in Melbourne. She has 25 years plus experience in academia and consulting engineering. Her research field concerns the long-term performance and durability of reinforced concrete and pre-stressed concrete structures, sustainability of infrastructure, rehabilitation of existing structures with fiber-reinforced polymers, multifunctional self-healing cementitious composites, recycled materials in concrete, and engineering education. Professor Gravina research is well recognized by the industry, and she continuously collaborates with civil infrastructure companies and agencies to support innovation and technology transfer. Please welcome our first speaker. Over to you, Rebecca. Thank you.
Thank you, Olivia, for that introduction, and welcome everybody to this presentation. I just want to confirm that you can all see, or Olivia, can you confirm that you can see the slides here that I am showing?
I can see it. Thank you.
Okay. All right. I'll just fix that up. Maybe not. Whoop. There we go. So what I'm going to present today and sort of set the scene for this discussion is one of the CRC, Smart Concrete CRC projects that I'm leading. This project is called Recycled Waste in Concrete for Municipal Applications. And we're towards the end of this program, so I'm really pleased to be able to speak on this topic today. This particular project looks at focusing on developing a Green Star rated ready-mix concrete for municipal pavement applications. It's really come about to address the need of how we can reduce the use of our virgin aggregates in concrete, and also try and also at the same time solve the problem of the increased amount of waste that's being generated in industrial, commercial and domestic sectors, and try and redirect some of that waste from landfill to other uses. And concrete construction materials is an area where we can apply or redirect some of that waste material, provided that it is of certain quality and performance requirements. And really that overview then, project really overview is looking at trying to develop a concrete that can reduce environmental emissions, and using these recycled materials as an alternative to partial or total replacement of cementitious material and also natural aggregates. Now, this project, as I said, is supported and funded by the Smart Concrete CRC program, so I'm very fortunate to have had that research grant support from the CRC and also the following industrial partners. So we worked with the Office of Projects Victoria in this project, and to establish the CRC project profile, and later on we had partners from Hanson and Mornington Peninsula Shire join us. So the project had several deliverables. Deliverables 1 to 4 have been 1 to 3 have been completed. 4 and 5 are in their completion stages now. So we worked on developing and optimised concrete mix formulations with different combinations of recycled materials, which I will talk about in a moment. Developed an experimental program that looked at the mechanical and durability properties of the concrete. Then applied the work that we'd done in the lab to upscale the concrete mixes in a local concrete facility, and then applied that upscaled concrete mix design to a pavement trial in a local council. We're currently developing, based on this work, guidelines for performance requirements for concrete with recycled material content. And we also have a PhD program that's coming to an end, and where we're looking at investigating the continuous recycling of concrete with recycled content also. So not just sort of, one generation, looking at how we can regenerate the concrete mixes that we've developed. So the concrete mix formulations and the materials that we've looked at consist of normal ordinary Portland cement. We've also incorporated ground granulated blast furnace slag, natural sand, natural coarse aggregates, and also looked at recycled crumb rubber and manufactured sand, as well as plastics that have been shredded and also grinded, so polyethylene PET plastics and also HDPE plastic. You can see here a little bit about sort of the different specific gravities of the materials, and when it comes to the recycled crumb rubber and PET plastics, we're dealing with material that's quite less in density than our typical aggregates, which will have a play in when it looks at what sort of impact we have with these mixed designs going forward. The mixed designs that we've developed look at a Portland cement to SCM content ratio of about 50 to 50, which is quite good, and that sort of and the Portland cement content is not over 180 kilograms per metre cubed, and so we've been able to actually achieve a concrete mix design as per the Green Star 3 rating. and our natural fine aggregate replacement is at a 30 to 60, well, 40 to 60 ratio. So the experimental program looked at the fresh properties, mechanical properties and durability properties. We tested our concrete mixes over a period from day of casting to 365 days. So we've got data for all this, all the mechanical properties over a 1 year period, which is quite good. The durability studies are quite lacking in this area. So to be able to capture the strength development as well as the mechanical properties as well as the durability properties in terms of shrinkage, creep and other durability characteristics has been a really good outcome from this project. The concrete mixes that we developed varied. We started with our control mix that had our 50 to 50% of Portland cement to SCM ratio, and then we worked with replacing the fine aggregate with either just crun rubber or just PET plastic fines. Or looking at a combination of PET plastic fines with crun rubber, or looking at also replacing some of the coarse with HDPE plastic, or a combination of the 3 different types of materials, PET, crun rubber and HDPE. So it's well known that as we replace the natural aggregates with recycled material content, in particular crun rubber and PET plastic, we do get a reduction in the mechanical performance. So we do get a reduction in the compressive strengths and the modulus elasticity, the flexural and tensile strengths, and the durability properties do get affected as well. But the important thing is to what extent do they get reduced, and if those mechanical and durability properties are still within acceptable limits, and do they still allow this type of concrete mix designs to be used and applied in the field. So I haven't got time to present all the results, so it's just sort of a snippet of some of the results that have been achieved. We also, in addition to the experimental program that was conducted over a 1 year time period, we also have developed a life cycle assessment tool where it looks at the system boundary of cradle to gate. So you can see it can find here in this slide here, where we're looking at what effect the transportation has of the materials to the concrete production batching plants, and what effect the cement production, SCM production, admixture production, natural aggregate and waste-based aggregate production has on the overall environmental analysis and life cycle assessment. Outside of the parameters are obviously, we haven't done a cradle to grave analysis, but that's part of the next sort of process as well, to see what impact that has in terms of our CO2 emissions. So what we find is that by adding some of this recycled content into our mix designs, we're not jeopardising too much the CO2 emission from the control mix. So provided for this, we're not getting a reduction, and I don't think we will necessarily get a great reduction in CO2 emissions by replacing natural aggregates with recycled aggregates, because there's still a process that needs to be undertaken to process that the material. So whether it's shredding or washing and sorting through, that does create an emission there. But what we can do is have some savings in the use of our natural aggregates, and also some savings in our landfill. Now, this has been calculated based on 1 metre cubed of concrete. Now, if you consider that each council replaces up to 15 kilometres of concrete footpaths per year, that's quite a bit of volume of concrete. So these savings actually are quite large when you look at the overall scheme for what's required for that material. So having done the LCA model, we chose the the concrete mix design that has a combination of PET, plastic and crumb rubber combined to replace our natural aggregate. So we've got a 40% replacement of the natural aggregate within the concrete mix design that's been replaced. We worked with Hanson and the local council, Mornington Shire Peninsula and DM Roads to identify a site and also carry out our field trial. So you can see here the two sites for the different types of mixes, our control mix plus the mix with the recycled material content, so the crumb rubber and the PET, and also the properties on the day from the concrete that was supplied on the day in terms of the compressive strength, flexural tensile strength, dry and shrinkage, and the slump. And look, it was a really good experience in terms of being able to work with the contractors and for them to get a feel of the material and what it looked like, and the responses were quite positive in terms of you know, how they were able to deal with the material, because there was quite a bit of slag in this mix. It did look different, did feel differently, so it's not sort of the concrete type of mix that most footpaths are constructed with, but yeah, the contractors were able to cast and finish and finish that. The concrete, apply a screed as well for the footpath, so we're quite happy with that outcome there. And you know, these sorts of trials, and I know they're happening all over the place, are really important because it gives the contractors and the people handling the material an idea of what to expect and how to you know, get the finished product that is required. So that was a pretty good, successful outcome. We also went back and have inspected the footpath over a period of time, and you can see here on the UQ PET crumb rubber mix design with the control slab as well, and where we've got quite a good you know, finished outcome. And you know, there's the concrete is performing. It's you know, there's not any sort of visible cracks that or anything like that you would expect, and yeah, so we're pretty happy with how that trial has gone. So that was pretty much a quick snapshot of this project, and you know, once all the results are finalised, they will be published and made more freely available. So these are my contact details, and I'm sure we'll hopefully this has provided enough information now, or sort of set the scene for our next talk, our next presenter to present on some of the other aspects that we've brought up in this presentation. Have I stopped sharing the screen there? I can't see if I have.
Yep, that's perfect.
Yep.
Thank you very much,
Yep.
Rebecca. Really interesting, and I think it was really good that you touched on when it comes to looking at the plastic properties of this material, this mix design, because that's always going to be the concern, is if we start changing mixes, how will that look? Specifically because we've been, I guess, looking at concrete and producing concrete in a certain way for many years. So changing that, you really do have to start changing, I guess, the perception and when it comes to handling this material. So thank you again, Rebecca. That was really informative. Moving on to our second speaker, I'd like to introduce Dr. Anumitra Michi. She has 24 plus years of experience in sustainability, climate resilience, project management, research, and strategic environment and land use planning, having worked in academia, private and government agencies, both locally and internationally, such as with the World Health Organization, Asian Development Bank, and Australian Department of Foreign and Trade. She is the founder and managing director of E-Resilience Planning, a sustainable consultancy specializing in ESG reporting, implementation of decarbonization of existing and new asset design, and embedded sustainable circular design solutions. She is also a founding member of MECLA and co-founder of Hunter Central Coast Circular Economy Facilitator Group, which has led a series of circular economy initiatives across the Hunter over a decade. In her role at Becker, she led various infrastructure projects embedded in sustainable, low carbon, and circular design outcomes. And Umitra is a passionate about built environment, construction sector, and as a visiting academic, continues to deliver the insights to build environment students. She's also a sustainable leader mentor for Cambridge University's Institute of Sustainable Leadership Program. Please welcome our second speaker. Over to you.
Thank you, Olivia, for that wonderful introduction, and a pleasure to be here. And thank you, Son, for having me. So I guess I bring the industrial perspective of the conversation today, and feel free to just drop your questions, and happy to take any questions at the end of it. Can you see my presentation?
Yes, that's perfect. Thank you.
Okay, brilliant. So I guess I bring a slightly different angle to our conversation today. The purpose of circularity, and how does the whole conversation come together for us to shift towards more sustainable circular design in our construction sector. So I guess why I think everyone in this group knows the reason why we need to transition towards more circular design. It is quite overwhelming to look at the global trends, and even in Australia we are not shifting the dial quick enough. If we are using more than half the global raw materials still in the mostly in the construction, that is alarming. In Australia, I think we only recycling 20 to 30% of the C&D material. But as you know, we now have a series of policy instruments at federal and state. We have a legislation that requires us to meet the emissions target for 43%, and we only have 63 months to 2030. I'm referring to 1st of January, I suppose, to get to that target. What does that 43% reduction look like? And on top of that, I guess we have a national waste policy, which we have to reduce total waste generated in Australia by 10% by person by 2030, and 80% average resource recovery by 2030. I mean, these numbers are staggering, and we don't actually have nowhere close to achieving this, and we'd only have 63 months. So I guess I just wanted to reiterate the reason why, what we're doing today and as a cohort, what you guys are all contributing towards. It's critical, it's crucial, it's fundamentally the need for everyone to come together to meet these massive deadlines we are trying to achieve. And as you know, post-COVID, 4% increase in raw material use has actually gone up by 4%, which is significant, despite all the efforts to make sustainable design. So I guess what is circular design? I'm going to just refer back to Jacqueline, Professor Jacqueline Kramer's work that and you're probably all aware of it, and just reiterate the 10 R's. And the first one, prevent raw material use. You've heard of all the rest of it, but what are we doing to actually prevent raw material use? We are consuming 1.75 planetary boundary resources as we speak. And our consumption is, of course, as related to our increasing population. But the construction sector, the demand for residential housing predominantly, it's huge. And so whilst there is a massive shortage of supply of material, there is also this never-ending growing demand for natural resources or raw materials for the construction. So I guess the question is, what does that mean in terms of reducing or preventing the use of raw material? Do we need massive built form? I have a mortgage broker friend. She keeps telling me that every day she approves minimum, her average is $2.8 million of home loans, and people are investing in massive footprint houses. Do we really need these type of houses anymore? What does that actually our future look like? Affordability for housing is seriously a problem in Australia. So really rethinking what we as individual buyers, homeowners, what we are building, what we're investing in, and what does circular design look like? So At Becker, when I've just recently finished from Becker, we developed this framework, circular design framework. The purpose of doing this framework, so, as you would probably be familiar, circularity through the Ellen MacArthur, they focused on 3 key perspectives, which is the 2, 3, 4 in this design around the material recyclability, material use. But at Becker, we extended that thinking and included the whole climate resilience, adaptation aspects and mitigation component to decarbonize future infrastructure. We brought in the cultural perspective because a lot of the time the culturally designed or inspired or values that cultural values bring into design is quite significant in reducing carbon footprint as well as the design aspect and obviously the socioeconomic benefit of it. So we used this framework to, I'll let the person mute, inform all the projects, so over 20, 30 projects that I've delivered in this very short period of time using this framework. The key purpose was to bring in that systems lens, the holistic approach to planning, and asking the right question at the right time of the project. So most of the projects at the beginning, my role was to really look at what the design aspect was. What is the design? Where are the opportunities to bring sustainability and circular aspect into it? And who do we need to talk to? So as a designer, as a consultant, my role is to really design provide better design output. However, that to become a reality needs the right key supplier, the right client appetite, etc. So bringing those, initiatives together was really the innovative piece, in my opinion, because we managed to achieve a number of projects where we were able to shift the dial and reduce the carbon footprint, as well as improve recyclability. So I guess from an industry perspective, as you know, there's a collective industry initiatives with the MECLA. A number of you probably are part of MECLA. There's been so many different things happening under that umbrella. I'm part of the working group Cement. So we've launched new standards. There's a local government new guidelines for low carbon concrete, and that's been trial at the local government scale. Lake Macquarie Council in 2019-2020, we were the first to trial road base using a high percentage of recycled and aggregate material. So there are a lot of initiatives happening, which is a great sign of that shift, and that the industry is being part of the solution. Industry is coming together in partnership. We had a number of following that 2019 handset on New South Wales government to increase the fly ash across the Hunter region. I probably speak of the Hunter region because I've been quite active in that space. We have trialed a number, so Newcastle City Council, now also Maitland Council. There's been a number of trials for pavements, and great to see, Rebecca, that initiative you're developing. The other aspect was for the water infrastructure. And so I would like to talk about one of the projects that I delivered, and really one of my career highlights, I suppose, was really the partnership, the collaboration between the client, which was the Transport for New South Wales, Becker as the designer, and Boral as the the supply chain, the provider of the material. We looked at a New South Wales bridge, and we modeled the bridge to understand where the high carbon footprints were. Based on that original design, because it's based bridges you have to build according to the spec. We did not have opportunity to play with that spec. So we looked at where the carbon intensive design looked like and where were some of those opportunities. So we brought in some of the sustainable opportunities to trial it with Boral in partnership. It was a parametric study to identify emission savings in the bridge design. So we looked at the substructures and superstructures of the bridge, which have the most carbon intensive design because of the key pillars and the footings, etc. We trialed about 5 different types of cement mixes at different MPAs. and 45 was the original design used. We looked at 60, 70, and 100 MPa, 80 and 100 MPa cement made from certain percentages of recyclates. That presentation and paper is online, so that's why I didn't share on this, and it's part of Becker's IP, so I didn't want to reiterate in my slides. But that project, in fact, achieved 15% reduction in carbon in the sub and superstructures using the 100 MPa cement, the high strength cement. That was a trial with the because the client, which was the TFS New South Wales, was keen to push that boundary. And what I want to iterate here is that when you bring the partners, the key partners into the project, you can really move the outcome of the projects. So we managed to not only just reduce the carbon footprint, but also reduce the quantity of cement used in that actual bridge design. Now that approach of thinking, we looked at the carbon, did the carbon accounting. We calculated the looked at the different strength where you can reduce the footing design. So usually it's a full pillar, but we decided to, if it was a higher strength cement, could you make the footing hollow in certain parts, so it still holds the strength, but at the same time the quantity of cement used is reduced. So that was really never trialed before, and something that I think was the first time to even come up with this, a 21% reduction from that design change, working with the structural engineers and bridge engineers. Now that concept is being trialed with Langerock and obviously TFS taking forward and providing further instruments for it. Now, government is also working very hard to make sure that the right standards are coming in place. They do take a lot of time, and that was one of the biggest barrier to actually bring about change. But there are massive initiatives happening, such as the procurement policies being written as we speak. Federal procurement policy provides that leadership, guidance, and strategic direction. But I think what's even more creative is that in the tender process, the clients are now actually putting it in that they want a low carbon design. They want to decarbonize, and such, for instance, I've did a number of projects with the Development Victoria. All their tender documents talked about 25%, certain percentage of reduction in material use, or ensuring that the climate risk component is embedded into the design thinking. So such as permeability component. If you're designing hard surfaces, what is the permeability, and can that performance of the pavement, for instance, and the permeability around the surroundings? What is the recycled material being used? Some of them actually are beginning to name them. And I guess I just wanted to, in this context, mention a few other things. The choices of material recycling. There was a big intake of glass for replacement of sand, but is it the right material for that? Is glass being optimized? Are we using the right material for the right purposes? Plastic is another big one, but have we considered the toxicity from the plastic for long term? Does it withstand heat at the increasing temperature? And making sure that the material recycling is serving its purpose and optimization of these material. So there's a lot of shift happening, no doubt, but there's a lot more needed. And hence the reason why research groups, CRCs such as these, are critical in bringing the right key stakeholders together to actually fuel this ongoing innovation and market-led approaches. I guess I just want to wrap up with where to. The key thing is it's about collaboration, not competition anymore. We all need to bring in our heads together to innovate, create, build that capability in the system. And where it works, scale it. scale the the understanding knowledge. For instance, the project we did with New South Wales Bridge project, that's now that learning from that has gone to other parts of the industry, and it's been taken up by other players. And it's refreshing to see that we no longer trying to compete each other, but we're trying to share the insights we're building. Capacity building is a key component, and as a university, Macquarie, I know, is really pushing that. University of New South Wales as well. Getting the graduates prepared for when I recruit graduate students in the role, it's a lot different what they have learned to actually practically apply. So bringing up to speed, upskilling not just the existing staff, but also the young graduates programs and training. Industry needs to provide some partnerships with universities to really provide that active learning opportunity, and bringing the the different skill sets, because it's not just about one lens of thinking. It's about the multidisciplinary approach to really innovate. Now, we talked about the procurement, the policies, the different instruments needed to improve the extended producer responsibility of products. That's really taking shape as we speak. And I think, was it early this week or last week, we have now got the new standards for circular economy, the ISO 59000, which is brilliant because it provides some really good lens, and I presume that will be adopted at a local scale and our national scale as well. Evidence-based, I guess we now have a lot of data building up. A lot of efforts are being put together to build that right data and performance of built form, and also future reporting. So on October 1st last year, the New South Wales SEP put in place a requirement for all the assets reporting the carbon emissions footprint existing and new, which really helps to start building the story. What is our current stock? Understanding the current stock and performance will only be able to build better performance down the track. So that innovation is critical. I'm an industry advisor or a mentor for a PhD student in Newcastle Uni. She's working on a material passport. We don't have one. It is a massive undertaking. Who's responsible for it? But at least a material passport, the concept of material passport now will help build that whole picture over the time. I already mentioned about optimization of material use and reuse. There is a really brilliant tool, Planet Price, which helps to actually look at the material used in the project design to understand its planetary boundary cost, so the societal cost of the material used. So we've been using that Planet Price tool in all our design delivery projects to understand what is the actual emission savings, what is the environmental cost of using this material now and into the future, and what is and it looks at 9 planetary boundary aspects. So things like ecotoxicity, social well-being, etc. And so having a innovative approach to rethink design and what does design look like, working with the key partners and stakeholders, really helps to fast track the transition towards circularity in the construction sector. And cement is obviously one of the most high carbon intensive material in the built form. So any innovation, any creation of new solutions will always be better than the original. So I think adopting the fast, accurate, automated and repeatable approaches to implement these new initiatives is obviously the way forward. And lastly, I guess, if you don't know how you're doing, how can you innovate and improve? So, having a system in place for ongoing monitoring performance. A lot of the time we are creating new products and material, but we probably not really able to measure the performance because these are long-lived assets and material. So just keeping abreast with how do we make sure that we build that in place. Don't consider monitoring and performance monitoring or even monitoring the performance of individual material use. At the end, it's like tick the box approach. built that into the design thinking from the beginning. So I guess I want to finish off with that circular economy is not just material use and reuse, but circular economy is thinking holistically, thinking about where do you start now? Is the current approach the right approach? Do we need to actually use these resources, or does it have a better approach to it? I've been in this space for more than a decade, trying to really fast track the circular design thinking. What I'm seeing now is probably the best time to ever be in sustainability, that circularity is taking shape and there's a lot more happening. But it's, again, a collective effort. It's not an individual person, not an individual sector. It's everyone coming together to make this a reality. So I'll finish off with that. Yeah, and happy to get any questions.
Perfect. Thank you so much again. Really interesting, really good presentation again. And I think it's important to emphasize the importance of collaboration, especially nowadays. Like, yes, you're going to have that commercial aspects and perhaps IPs that will be involved in some of these projects. But at the end of the day, we're all part of the industry. We're all a part of that supply chain, and we all have a part to play when it comes to decarbonizing the industry. I think it's also really good that you emphasize the importance of academia and industry aligning when it comes to whether that's PhD students or any individuals of such. I think it's important to really understand where is the industry moving towards, and are we seeing that in the academia? It's important to have that aligning, and I think that's also one of the main reasons why we have these community of practice, to really ensure that we are aligning and we are understanding what academia is doing, we're understanding what the industry is doing. So once again, I really want to thank both of the presenters once again. Really, really good presentations. So right now it's time for questions. And as mentioned at the start of this meeting, you can either raise your hand or you can put your question in the meeting chat. I can already see that there's a few questions in the meeting chat, so thank you for that. I'll just start with 2 questions while others put their questions in the meeting chat. So just to kickstart for yourself, Rebecca, when it comes to the supply chain for some of these recycled materials, what is your concerns when it comes to actually obtaining those materials, but also using it on a production scale long term?
Thanks, Olivia. So I think regardless of the material you're using, whether it's a recycled material content or anything that you're going to introduce into concrete production, the reliability of that material is very important, that it sits within the sort of particles. If we're looking at aggregates, the particle size distribution is consistent, so that we can design concrete mixes that are reliable and provide the performance measures that are needed. So when it comes to the supply of crumb rubber or PET plastics or recycled glass, as was mentioned earlier. Even the same for if we're replacing our Portland cement with other supplementary cementitious materials other than fly ash and slag is also very important. And also, having the information available about what the product is and what sort of any sort of what the chemical composition is as well. So having all that information freely and easily available, so we know what we're dealing with, is really, really important. So so I think that's something that I think any sort of suppliers will be considering and probably may be challenging at the moment too. Olivia, I noticed there's some other questions on there. If you about plastics, I think was one of the first questions there, and I just would like to elaborate a little bit about that. There's a question that asked about the deterioration hazard and implications of plastic. Look, it's very important that we're using and plastics is a general term. You need to know what type of plastics you're using. So, you wouldn't be using soft plastics in concrete. They degrade under UV in a concrete mix. If you're using PET, we know that it has good UV characteristics and performance, and HDPE plastics. So that's why I made it very important that I was specific about the type of plastic recycled material use in these concrete mixes. that can have an impact. When it comes to microplastic analysis, with these concrete mix designs, the plastics are very well embedded within the cement paste, so it's not exposed to the UV in that respect. When we're talking about, you know, smaller plastic particle sizes, not nanoscale in terms of microplastics. We're talking about fine aggregate sort of particle size distribution. And there was also a question there about abrasion resistance. Now, we have done abrasion resistance testing on the concrete mixes that we have developed. We found that with a crumb rubber and PET mix combined, it actually improves the flexural tensile strength of the concrete and can bridge between the aggregates and the cement and provide actually improved abrasion resistance against, say, our control values as well. So we're not seeing that the abrasion resistance is any worse. In some cases, it's actually improved because of that flexural rigidity that's now coming into the concrete material performance values. So I thought I'd take that, just mention those sort of questions which sort of relate to that material supply questions as well. So yeah, thanks, Olivia.
No, that's perfect. Yeah, there was a lot of questions on the plastic, so thank you so much for covering that, Rebecca. A question for yourself and Yumitra. You spoke a little bit in regards to designing of concrete. Just a quick question, has there been a shift across the board in regards to the design work, and is it aligning in regards to reducing the embodied carbon in concrete? Is that where we're kind of moving towards?
Yes, so since the last 2 years, I've seen a significant shift in the way mostly the government agencies are leading this. There is all the new tenders coming out now for major infrastructure design. They have circular principles in it because the legislations were passed, let's say 3-4 years ago now. Victoria has a Circular Economy Act and New South Wales is a policies position. So the tender work specifies, but they used to have a broad statement in the beginning. Now they're actually specifying that we want 40% recycled. We want X amount of X material used in the design. And a number of the clients now also have a carbon footprint attached to it. So what we are doing now, for instance, Melbourne Airport, the M3R project, each apron is where the new, the planes come in, taxiway and all that. Each apron, we did the carbon footprint of the original concept design and looked at the design and went, okay, this is what the footprint is. This is Melbourne Airport's emissions budget, so carbon footprint budget. And we work backwards from that to go, all right, where are the different opportunities to reduce carbon within this design? So even though we're looking at the carbon tunnel at the start of the conversation, but then we're building in other aspects such as material use, localization, transportation emissions, social component, like bringing in the local contractors on the project. So Melbourne Airport is one of the good clients who's really pushing the boundary of trying to bring in all the different things. But I guess that shift towards circularity is fast becoming a new norm. However, there is a bit of a disjoint on, okay, we want to design better low carbon product. And then there is the other concept around resilience, like how do we build for future climate? What is how does circularity meet that design performance? So that's where I think that is still growing, building, because resilience is very specific to the context of the space, location, weather context, changing weather patterns. So if we are going to have more rainfall pattern in the future or more drier conditions, will the current design built on this current recycled products and material be able to perform in that future? Don't know the answer to that, but we can trial certain things and that's where I think CRCs and like sandbox approach to actually build new design, what we did with the bridge project, helps to really bring certain unknown risks in the forefront, so we can start thinking about those. And it's very fresh at the moment. We don't really know what the performance in the long term would look like, but these new insights coming from an industry perspective are quite refreshing, and definitely needs more work.
That's perfect. Thank you so much. And you are welcome to stop sharing. Your screen is still there, just so that everyone could see you a bit bigger in the. That's
Didn't
perfect.
realize.
Thank you so much.
Didn't realize I was still sharing.
Technology, all good. Thank you so much. Okay, we'll go on to some of the questions in the chat. And thank you, Rebecca. You've covered a lot of the plastics, but there was another question for you in regards to, can you expand to look at biochar?
Sure, we can. I'm not sure that work is being done, and I think when we consider any sort of new process or any sort of new material, we also need to couple that with the environmental impact that has. So to create a biochar requires a lot of energy as well. So we need to be balanced to make sure that what we're producing is going to provide an environmental benefit in the end, and not increase that environmental impact.
Yep, of course. A question for yourself, Dr. Enyumitra, in regards to what ISO you referred to. I'm not sure what slide they're talking about, but you must have mentioned an ISO standard.
Yeah, so it's ISO 59000, so 59,000. It's very fresh, very new to the market. And in regards to biochar, I just wanted to add, we do the carbon calculation of biochar processes. And at the moment, there are multiple trials in biochar happening, but is it economical to use that in cement production? I guess at the end of the day, biochar is being used for more agriculture purposes, but to produce biochar to be used in cement, it's just another massive carbon footprint.
Thank you. I definitely know biochar is used as alternative fuels in cement manufacturing, so there is that aspect of it there. A question from Nikki Jackson, and Nikki, if you would like to jump in after I ask this question, feel free to, just to have that conversation. But the question from Nikki is, as note, if using the Meckler guide to low carbon concrete, the definition is to ensure that the concrete has the same performance as the reference. Based on the presented results, the control and the PET CR60 are not comparable. The PET 60 and CR 60 is more aligned to a normal class 20 MPa concrete. Based on the published EPDs and class 20 MPa with fly ash in Queensland, they range from around 200 to, I guess, above that when it comes to the CO2 embodied carbon. So I'm not too sure exactly what the question was there, but Rebecca, did you want to elaborate? Because I know you touched on this.
Sure. Look, that's a valid question. Thanks, Nikki. Look, we know by adding recycled material content, especially the chrome rubber and any other sort of fine aggregate replacement, we're going to get a reduction in material performance. So it wasn't, well, you can look at it two ways, I suppose. What we were trying to achieve is a concrete strength of around 20 MPa with recycled material content, so that we could still meet the performance requirements of a footpath. But there's going to be quite a variation in the control in terms of yes, we're going to get a reduction. It's you can't achieve the same mechanical strength in that respect. So yes, it's I mean, you can look at it in lots of different ways, and yeah, I don't want to get into the argument about it's not the same control and all that sort of thing. But look, it's very hard to compare apples for apples when we're dealing with recycled material content in that case.
Sorry, just muted that participant. Thank you, Rebecca. Really appreciate it. And just the last question, once again, on plastics. Microplastics are dangerous for breathing and a health issue more than concrete. The release of microplastics is avoidable during demolition. Is that correct? Yeah. Both of you.
So I'll just make a quick comment, and then maybe Amitra might like to add, if she's got some knowledge in this area as well. We're not dealing with, I mean, the type of plastics in these particular mixes do not necessarily generate microplastics because that's at the nano micro scale level. They don't degrade down to that level. But if you're looking at the concrete mix that has these particular recycled material content in there, yes, when you're crushing them, the plastic, the PET and the crumb rubber will sometimes be dislodged from the cement paste, but we can reuse that back in as a fine aggregate replacement. But microplastics is probably, I mean, it depends how you're defining it, and I can't say that I'm an expert in that area, but I know that it is a concern for others. But what we've tried to do is use plastics that we know that don't degrade down to that microplastic, that sort of nano micro scale. But if anyone else wants to chip in, they can.
I certainly am not an expert in it. I've only just done carbon calculations of all the plastic types, but really the nanoparticle release from demolition, it's just not something that I'm familiar with. I'm sure you guys are, but maybe that becomes a new research topic, right? To further investigate.
And we just had another question. Thank you both. We just had another question come in. For a pilot project such as Bridge with the hollow foundations, how is the risk handled and distributed?
That's a very good question. I'm not the structural engineer. I'm the sustainability person who tries to push the boundary. So that would not be something that I could truly answer with full due diligence on that question. But fundamentally, my understanding is that normally the footings are fully concreted pillars. However, in this instance, the actual boundary of the footing at the bottom was basically like a wall created around it, rather than having this huge dump of cement going in. I suppose you structural engineers would know more about it. The thing was that will the bridge pillars still be able to withstand different water movement patterns, and does the performance change in this instance? Would the 100 MPa have brittleness, etc. Those are the ongoing investigations at the moment with TFS New South Wales, and so yeah, I'm sure more will be coming out.
Perfect, thank you. Well, those are all the questions that we had today, and just about to close off our session. I would like to thank you both once again so much, and thanks Smart Creek again for their support with this community of practice. It's been very informative. Just learned a lot around, I guess, where we're currently at in the industry, where we're moving towards. Once again, if you have any additional questions, please feel free to reach out to the presenters directly, myself, or even those from Smart Creek. Once again, thank you so much for your time, and we'll meet again very soon. Thank you all.
Thank you for having me.
Thank you very much, everyone. Thank you.